Hi, we are from Team 9 working on the project using the Autonomous Vehicle Cloud. Our project, which we would like to call it as a AV rental application, is an end-to-end application that allows user to rent autonomous vehicles to commute. Before moving on, we would like to acknowledge Dr. Jerry Gao for giving us this opportunity to work on a cutting-edge project. We appreciate his guidance and relevant course materials that helped us successfully complete our project. Our team includes Vijayani, I'm Sanjana, Shraddha, and Venkat. This application has three users. One, a car user who books an autonomous car to commute. Two, a car owner who owns the autonomous car. And three, a system admin who manages and helps in improving the application. We have developed our application using Flask. The databases used include MySQL, MongoDB, and S3 Bucket. And most importantly, we have hosted using Amazon Cloud Platform. Amazon offers Elastic Beanstalk service, which handles the scaling, management, and security concerns, thereby providing an easy-to-use service for deploying web applications. AWS Elastic Beanstalk environment includes an auto-scaling group that manages the Amazon EC2 instances in our environment. In a single instance environment, the auto-scaling group ensures that there is always one instance running. In a load-balanced environment, we configure the group with a range of instances to run. Auto-scaling adds or removes instances as needed based on load. The load balancer sits in front of the Amazon EC2 instances to direct the load to suitable instances. So this diagram basically explains what we just said. This is our Elastic Beanstalk view where our application is deployed. The EC2 instance where the application is running. Here is the load balancer created. And this is the auto scaling group. We have allowed maximum of 4 instances, EC2 instances to be created depending on the load to the application. The application is monitored using CloudWatch, and these are some of the stats available for our application. Now I'll hand it over to Shraddha to go through the application.
Thank you, Sanjana. So this is our AV rental login application. And in order to use this application, we first need to register ourselves. So let's register ourselves. So we'll click on create account. So as already discussed, there are 3 users for our application. So we will try to register a car owner. So here we can select the roles, which is car owner, car user, system administrator. So if we select other roles such as car user and system administrator, the fields below will be disabled. But we are registering a car owner. So we'll select car owner and we'll provide the car details. So after giving the required details, if we sign up, we have successfully created a user account of the role car owner. Now we will try logging in through this username. This application also checks for duplicate users. So as we can see here, this is a new user and this is a car owner. Every role has its own individual dashboard view. So this is the car owner. So he can see his car information, which we just used to register. And since this is a new car owner user, there are no rides taken for this car. That's why the rides taken table is empty. So we don't see any information here. And the available amount, which is the total cost uh, which the car owner will get is also zero because this is a new user. We also have a functionality of the user profile wherein we can see the user general information and we can update it also. So as you can see, it gets this information gets saved in the database and in the user profile. We'll also look at the our MySQL DB. Here we have three tables, AV rental login, which saves all kinds of users, AV rental cars, which saves all kind of cars which are registered in the system, and the AV rental rides, which saves all the rides. We can check the information of the user which we just created. As you can see here, the record is correctly saved in the DB. Now we will log out and we will log into an existing car owner account. Passing on to Sanjana to explain further.
Now let's go through the process of ride booking and billing components. Let's go to a car user. Let's log in as a car user. His dashboard will cater to the user to book rides. Let's go ahead and book a ride here. On click of the book ride button, a car of the selected car type and whose status is inactive in the DB is provided by the system to Rick for the ride. The estimated travel time and distance is retrieved from a Google API using the source and destination that was given. The base price is set to $2. So, and that's how we have calculated the estimated fare using the distance and the base price. So, in trip details of the car user account, uh, we can see basically the available amount in the user account and the list of current and past rides taken by the user. As you can see here, this is the recently booked ride and its status is booked. Once the car is booked, the Carla receives a ping to start its simulation. I'll hand it over to Bujani to explain the Carla simulation and the change in the status of the ride in the dashboard.
Hi everyone. So once we get the ping from the UI, the Carla simulations will start. So we have the Carla world up and running here. So we will simulate our car over in this particular environment. So our car is attached with four sensors. The first one is GNSS sensor. It gives the longitude, latitude, position of a particular car. So these data are collected by our system. Then there is a collision sensor. So if and when the car encounters a collision, that data is also stored and will be stored further. The third is a lane intervention sensor. So each and every time the car crosses a broken line or a solid line of a lane, of a specified lane, those records are also stored by us. And then there is a RGB camera. This RGB camera takes the picture of the surroundings and we save it in the database for further use. So let's try and start our car. Let's simulate a car. So we will get the destination from the UI. So that is Santa Clara, and we will start our car. So once the car has been simulated, as we can see in the world, the car has started. Let's go to the UI screen and see if the status gets changed. So the status gets changed to in progress since the trip has started. So next, let's see, once the trip gets completed, it will end somewhere near the traffic light where it will stop. The destination will be reached. Yeah, so the car has stopped and we have reached the destination. So we have uploaded the GNSS details and the lane invention details in the DB. And since there was no collision, no such data was updated. Let's go to the transaction screen and see for the user. Here we can see the amount has been updated and the trip status has been changed to completed. Similarly, for the owner's page, if we can see, yeah, so I think this is the one, the last one that is in sync with the latest booking. So this is the one, the amount has been updated, the status has been changed to complete, and this amount is also added to the user's available amount. So this is the amount available, I think was the, yeah. So this is the whole flow. Passing on to Venkat for showing the admin UI.
So I'll be giving you a demo of the admin's UI. I'll be showing you the functionality that he has and what he'll be using to assist the users and car owners. So here we have the list of all the cars that are registered in our application, and and also we have all the users and the car owners and their information so that they can be helped when they need any assistance with logging in and something. And also we have sensor data that is being uploaded onto MongoDB from the trip. So the MongoDB can be accessed by the admin only with this login ID and password. Um, there is no collision data updated as of now because this trip doesn't have any collision, so there's no collision data for this trip. When I go into DNS details, it gives the uh, latitude and longitude of the current of every trip, and the and the object is given with a trip ID and is associated with the trip ID, so that the trip can be located easily. It also has the lane information data. This initial data is also linked with the trip ID, so that it can be used to find the user who has got this, who is associated with this data. And also we have S3. I'll be logging in with my credentials to access the images. So here in S3 we have a bucket named the RGB camera output. In that we have all the images that are being uploaded from the dash cam. So as you can see, this is updated after every trip has been ended. The images are being uploaded onto the cloud. So if we click on this and we access the URL, we have the image that is being downloaded onto our system. So this sensor data and the image data is not only used for the logging purposes, but also can be used for analytics to help improve the autonomous vehicles in driving better. So that's our application.
Thank you.